Hi, everyone. I hope you're all doing well. Today, I wanted to talk a little bit about the behavioral aspects of emotional memory, so our second to last chapter for the semester. And there are some tricky aspects to this chapter that tend to give students trouble. And so I wanted to highlight just the different examples of learning emotional responses that you read about in the textbook. The good thing is that these concepts work off of operant and classical conditioning, which we've talked quite a bit about, but they're very specifically contextualized to emotional learning. And as you read, that usually means they're related to negative emotions. That seems to be where we have the most understanding and the most knowledge about how emotions work behaviorally, and when we head toward talking about the brain as well. Um, there's more and more about positive emotions too, but a lot of what we understand comes from fear in particular, and the more negative emotions. So, as briefly as possible, I'm going to talk through four different types of emotional learning, the first of which is going to be rooted in classical conditioning principles. And then the other three are all related and tied into each other. And for the most part, work off of operant conditioning principles. But first, the most popular of these paradigms is called conditioned fear. This is widely used in animal species in particular. Lots of animal models use this. Um, and it's where we pair a neutral stimulus, right? So back to classical conditioning paradigm, something like a tone that wouldn't necessarily have any particular response associated with it. And we pair that with a painful stimulus, so that would be our unconditioned stimulus. And a lot of these studies are done in rodents, although, we'll see, dogs and cats and other similar species as well. And it's usually something like a foot shock, right? So the floor is electrified or can be electrified. And so that's how we give that painful stimulus. And so basically, that then conditioned stimulus, for example, a tone, comes to evoke a behavioral fear response on its own in the absence of the foot shock once that association is learned, right? And so this is a really powerful paradigm because we can look at what we would call more overt behaviors like freezing, right? So animals, and in particular rodents, when given a painful stimulus like a foot shock, will actually freeze up. Um, and then we can also look at the physiological responses as well. For example, something like elevated blood pressure. And so this kind of paradigm lets us look at both of these responses. It's learned very quickly, right? So if you remember back when we showed kind of the general graphs of classical conditioning learning, it takes many trials usually for associations to be learned. This is a bit of a caveat to that, in that fear responses are learned a little bit quickly. And they're also very hard to extinguish once that association's learned. It tends to stick around a little bit longer than more neutral or less emotional types of classical conditioning learning. And it is relatively ubiquitous. We can see this in lots of different species. And because there is that conservation, we do use animal models a lot to study this. So you can see just the behavior, right? It's very powerful. So, if you look at, for example, data from the first time a tone's presented before it's been associated with anything, animal doesn't really freeze much, maybe stops to pay attention, right? But doesn't really have any particular association with it at that point. But then after it learns the pairing with the shock, right? In this case, 4 times as long freezing duration following that. We see similar with change in blood pressure as well, right? So this is for, an example of a given trial, right? First time the tone's presented, right? Blood pressure does change a little bit, just, kind of in conjunction with that freezing response, right? It notes the tone, but, then it quickly goes back uh, to baseline. But after that tone shock pairing is learned, we see the big spike and it stays elevated a little bit afterwards, right? So we can use this kind of classical conditioning paradigm to study behavioral and physiological changes associated with learning a fear response. Now, like I mentioned, the next three are going to be related to operant conditioning, and they are all tied in together. So we'll start with the simplest version of this, which is called conditioned escape. So it works off of negative reinforcement. That is, if the animal engages in a particular response, that response is going to remove some noxious stimulus. And so a really classic example of this, again, still using foot shock, would be that an animal learns that if it's given a foot shock, it can make the foot shock go away if it presses a lever, right? So the foot shock comes on, animal learns that if it presses the lever, the foot shock will go away. So that's removing a negative stimulus, and because that's removing something bad, it's going to increase that behavior. So that's a negative reinforcement paradigm. Another example that we use a lot in these kind of studies would be putting an animal in a cold bath of water. If there's a platform to escape to, very quickly we'll learn to swim and find that platform, right? So again, just like the classical conditioning version of this, it's learned very quickly and also relatively hard to extinguish. So these tend to be long-lasting associations and memories once they are learned. Now, conditioned escape in certain contexts can become what we would call conditioned avoidance. That is, the animal can actually learn to, if there is an opportunity, to never actually experience the negative stimulus once it learns what to do. So what this can look like, in this case, we have a shuttle box, which is a room with two separate compartments, and there's a barrier, but it's a barrier that can be transverse. The animal can jump over that barrier. And both sides of the room have electric floors. That is, we can turn on electricity, which would give the animal a noxious shock on their feet. So in this case, we have lights on both sides. And so we can train such that this light becomes a discriminative stimulus. That is, the light turns out, and then the floor is going to be electrified, right? And so an escape would be the animal, once that floor turns on, is going to jump to the other side of the box to eliminate the feeling of the shock. So it's escaping that feeling of shock, right? When the light's out, right? If jump, shock ends. So that still works on the basic operant conditioning paradigm, right? So this is a variation of conditioned escape. The difference here is that, in the example with the lever, right, the animal always has to go to turn off the lever once the floor turns on. What's different in this scenario is that we've added this additional discriminative stimulus that's telling the animal what's going to happen before it happens. And so in this case, what the animals tend to learn is that they can actually jump over the barrier before the shock even comes, because the light turns off first and then the floor is going to electrify. So if the animal learns that association, it's going to jump and avoid the shock before it even happens, right? So in this case, pre-training, right, the animal hasn't learned any jumping to happen that. And then in initial training, the light goes out, the shock's applied, and it jumps over the barrier, right? That's escape. But as this continues, the animal learns the association of that light turning off, such that the light turns off and it jumps before it even feels the noxious stimulus. And so at this point, they're no longer escaping a bad situation, they're avoiding it altogether. So that's why we call this conditioned avoidance, right? And so this is something that we can see quite a bit in the real world as well. I think if you think about it, you can all think of ways that you've learned to avoid being in situations that you find uncomfortable or situations that you find bad based on contextual cues, right? And so you're not even experiencing the bad thing anymore, but you've learned to avoid a certain situation altogether, right? And this kind of learning seems to be maintained relatively indefinitely. That is, the animal is really good at learning this association, and it's never going to receive another shock in this context. Every time the light goes out, it jumps before the shock even comes. And so this should start to seem a little weird based on learning principles that we've thought about. Why wouldn't this behavior extinguish at some point, right? What maintains that response when the negative reinforcer is no longer experienced, right? And so this is something that has given psychologists and neuroscientists now a lot to think about in terms of what is the mechanism that keeps this learning, this memory alive when there's no more reinforcement to keep it there. So two different ways of thinking about this have come to the forefront, and there's not necessarily a right answer, but the two-factor theory would argue that we don't see extinction because the light itself becomes a conditioned stimulus. And so the animal, right, is now conditioned to, right, this is predicting the shock, right, and you're going to, you know, engage in the response that's associated with that shock, right? Not the best explanation in a lot of ways, at least in my opinion. But the cognitive theory, right, it doesn't necessarily give you a lot of meat to work with. But if you think back to what we've talked about before in terms of matching up our expectation with results, and when there's not a deviation between our expectation and result, then we don't necessarily learn anything new that's going to change our behavior, right? So the cognitive theory argues that we don't see extinction of this behavior because no expectations have been challenged, right? The animal learns that if I jump, I'm not going to experience a shock. And every time they jump, they don't experience the shock. So there's no reason to update their schema at that point. There's no reason to update how they're thinking about the situation, right? So these are how, you know, people have tried to explain why we don't see that behavior go away. It lasts, like I said, relatively indefinitely when people have tracked this kind of behavior out long after the training has actually occurred. The last piece of this, which also, again, is kind of part of the same idea, is learned helplessness. And so this is something that you likely have all heard about before this class, and this is kind of one context that we can put this in. And so, you know, for those of you in history and systems right now, you know, reading about Seligman and some of his work kind of as we speak or a little bit earlier, what they found and related to learned helplessness is that prior experience with different types of situations can alter avoidance learning. And so in particular, they looked at this idea of learned helplessness. That is, if you put an animal in an inescapable adverse environment, it can impair their ability to later learn to avoid negative stimuli. Right? And so you're likely, again, all somewhat familiar with this paradigm. It is something that has, you know, become into kind of popular knowledge, right? But if we expose an animal to several unavoidable shocks again and again, the animal seems to, both in disposition and in behavior, become kind of helpless in nature, right? Even to the point where later on, right, if you remove that additional barrier, they have the ability, right, we have the same discriminative stimuli to learn that association. We see in behavior that the animal seems to have given up, that we see very low rates of avoidance learning at this point. They don't even bother trying to escape, right? Not just learning how to avoid the shock, but they won't even jump to the safe side of the room when that barrier goes away and the foot shock comes on, And so this has been something that has gotten much work and attention since their early work in here. And the things that get really scary, but also help apply to human situations as well, is that we see a lot of generalization of this behavior, right? So training an animal in this context, not only will they not learn how to protect themselves or avoid noxious stimuli in this environment, it tends to impact them in other ways outside of that specific situation. So different types of learning paradigms outside that room, decreased effort overall, and in ways that we can measure animals' mood, they seem to show signs of depression as well. A positive of this is that we've also started to think about the concept of inoculation, because not everybody, especially when we talk about humans, shows the same kind of learned helplessness effect. While we have used it to explain depression, right, not everybody in the same situation is going to develop symptoms of depression. And so one thing that we've learned is that if we give people, especially early in life, or animals, if we're talking about a learning paradigm, chances to succeed and chances to control averse stimuli in their environment, that even if we then put them through a learned helplessness scenario, they tend to do better than at learning to escape or avoid when the situation arises. Right. So if you have some prior experience being able to control a bad situation, that might make you more able to push through a bad situation later. Whereas if you don't have that experience, or if you've been in previous situations where you don't really have much ability to impact negative things in your environment, it can even make it worse. And so this is translated into so many areas of psychological research, because especially when we think about children, if they've experienced, helpless situations, that can have an impact not just in that part of their life, but it can spread. And when they experience or are exposed to potentially negative situations or helpless like situations in the future, that they can be even worse off than not even having the ability to um, impact their environment as it is. And so this has continued to be a very interesting and growing area of research to try and understand how we can recognize these situations, how we can try and give people coping skills ahead of time, even if it's through giving them ability to impact and make decisions and remove negative things from their environment in that way. So again, um, especially with the three kind of operant conditioning related paradigms here, because of the overlap, sometimes that can be confusing. If you want to ask follow-up questions about this on the discussion board, please do that. I'm happy to talk more. And don't forget, right, a lot of the early part of this chapter is related to theories of emotional processing. So you definitely want to be familiar and be able to talk about Cannon-Barr, James Lange, two-factor theory, common sense theory of emotional processing, right? Because those can also get a little tricky and overlapping as well. I hope that you and your families are still doing all right for the most part. Please let me know how I can help if I can. Otherwise, I will be back soon with a video for some stuff about the amygdala related to this chapter before we head into our final chapter on social learning pretty soon. All right.